This video will show you how to graph a reciprocal function and its original on the same axis, but this time we're going to end up with a function that just has one zero, and that's its vertex. So let's take a look. We have x squared minus 4x plus 4, and we're going to graph it and x squared minus 4x plus 4 all under 1, or the reciprocal function of it. Let's begin by factoring. What multiplies to 4, we're factoring the original here, and adds to negative 4, the only possibility is negative 2 and negative 2. So we have f at x equals x minus 2 times x minus 2, or x minus 2, put an equal sign here, x minus 2 squared. Well, that means there's only one 0 at 2 comma 0. And so that means the axis of symmetry, pretty easy to find. There's only one 0, and that 0 is the vertex. That is to say, look at this form. Yeah, it's x minus 2 times x minus 2, but we can write that as x minus 2 squared, and then we could see vertex form. It's just got its axis of symmetry right at x equals 2. We don't even have to sub in to find what's the y of the vertex. We know it. It's 0. In other words, when you have this 1, 0, we're happy here, because with only one 0, it means that 0 is the vertex. It has to be. Think carefully. If you only have one 0, how could that be anything but the vertex of the parabola right on the x-axis? So I'll draw my x and y axes here, and I'll label them x and y, and I'll make my scale. And take your time to make a nice scale. Make nice even ticks, label them. It's important for communication. Alright. Well, I've got more work to do. I want to be able to graph the reciprocal too, which is the same as the function was x minus 2 squared, so it'll be reciprocal 1 over x minus 2 squared. Wherever there was a 0, 2 comma 0, there'll now be a vertical asymptote. So there'll be a vertical asymptote at x equals 2. And we know that reciprocal functions always have a horizontal asymptote at y equals 0. They're going to share any points where y equals 1 or y equals negative 1. And if the vertex is 2 comma 0, the reciprocal of that vertex will be 2 comma 1 over 0. Hold on a sec. You can't have 1 over 0. That'll be undefined. You won't have a reciprocal vertex, and that should make sense. There can't be a reciprocal of the vertex because the vertex is the 0, and at that 0 we'll have a vertical asymptote. Let's see how that looks. Let's start by graphing the original parabola. It's only got one 0 at 2 comma 0, and after that it opens up. I can tell by the coefficient of 1, the step pattern is over 1 up 1, and then over 1 up 3. So I went over 1. Oh, it looks like I went up 2. That's no good. Over 1, up 1, over 1, up 3, and then over 1, up 5. 1, 2, 3, 4, 5. And we'll do the same on the other side. Over 1, up 1, over 1, up 3, and over 1, up 5. So there's my original parabola, quadratic, but only with its 1, 0. And now it should become obvious. This 1, 0 is in fact both the vertex and the 0, and that's where our asymptote's going to be, at x equals 2, as we found here. We also have a horizontal asymptote, make little ticks just visible to the reader, at y equals 0. Should also not forget to label my original function f at x. So for my new function, it's going to be bounded by these horizontal and vertical asymptotes, and it's got to share the point at x equals, at y equals 1, or y equals 1, both sides here. There's no spots where y is negative 1. It never goes below this 0 here. And notice you can't have a reciprocal of this vertex, because that reciprocal would be somewhere on an asymptote. Impossible. Instead, we just draw the reciprocal function, we're ready to do it, that travels right along close to the asymptote, staying with it the whole time, except to come up through that point they share at 1, a height of 1, and then travel along this asymptote. And same thing on the other side. It'll travel along the asymptote, staying really close to it, and only coming out to go through that shared point, and then it comes down along, but never touching the asymptote. And so these two pieces, that's typical shape of a parabola with 1, 0 when we take its reciprocal. In other words, we have graphed the reciprocal of a quadratic that had 1, 0.